So I wrote out some example problems. They should be pretty interesting and fun. I'm excited to do them. And it's actually all based off of a comic book. Because physics is applying math to the real world. And if we're applying math to the real world, then we should make it fun. And the way I'm making it fun is I'm just saying, all right, let's do a comic book instead. So I started drawing this stuff and I didn't have time to finish. But anyway, let's talk about this one. I'm just going to do a bunch of example problems, and I won't even read the story to you. I'll let you guys read the story. But let's do this one. Ready? Example problem number 1. Someone's flying in a helicopter. So we've got ourselves a helicopter that's over here. I don't know, I draw terrible helicopters. As you can tell, if I have a lot of time, I'll actually be able to draw a nice picture. But, you know, for now, I can draw ugly pictures. This is a helicopter, and it's moving at a velocity of 100 miles per hour. Is it miles per hour? Or meters per second. That's a pretty fast helicopter. It's not the fastest I've ever seen, but it's pretty fast. All right. So it's moving at 100 meters per second, and its height is 1,000 meters. I actually put 1K, but that's the same as 1,000. Where does the bomb strike relative to the ground? So it releases a bomb over here, and it's not a rocket-powered bomb. It's just a regular bomb. So it releases a bomb. The bomb kind of goes pew, and then falls and hits the ground. It explodes. Lots of death over here. Actually, they're firing it at 2 people, so there's only 2 people to get blown up or whatever. But don't worry, that's not the end of the story because I keep these characters around. So anyway, I keep rambling. Let's move. Let's do this one. Ready? So what we talk about is we look at the y direction. In fact, I know I'm doing these example problems for you. Can you actually see this? Is this too hard to see?
I can't see it.
This is a frustrating day for me. All right. How's about now?
I mean, kinda. Do you have a black pen?
I do, but my black pen ran out. It's like I have tech issues all day today, and then all of a sudden, my pen started dying. So now I have, like, physical issues. So pretty much the theme of today is Mr. Dallday's got issues. Is that better?
Yeah.
Alright. So I'm going to be looking in the y direction, and I basically fill out my variables. The 5 different variables we have to talk about is v final, v initial, acceleration, time, and delta y in this case. Usually it's delta x, but since we're talking about the y direction, we want delta y. So what is our v final? Do we know it? No, I don't know it. But you know what? I don't care about it either. What is our v initial? In the y direction, what is our v initial? I'm going to just ask you guys. What is our v initial in the y direction? Rhymes with hero. Starts with a Z. You can say it out loud if you want. 0, there we go. It's 0. The acceleration in the y direction is actually negative g. The time, well, that's what we want to figure out, and the distance it fell is 1,000. See, right there. So we apply our equations, and the only equation we're going to use is the delta x equals v naught t plus 1 half at squared. But in this case, I'm changing it to a delta y. So it's delta y equals v naught t plus 1 half at squared. This.
Wait, you could just change the x and y like that?
Well, yeah, because delta x represents a distance, but in this case, we're talking about the distance in the y direction. So I'm customizing that delta x equals v naught t plus 1 half at squared to the y direction. So technically, I should have a little subscript y over here and a little subscript y over here. Which this means This is the velocity initial in the y direction times time. Because the velocity initial in the y direction is different from the velocity initial in the x direction. Velocity initial in the x direction is 100. Velocity initial in the y direction is 0. Am I making sense here?
Kind of.
We've been going through this for the last 3 weeks, so hopefully this is like pretty rock solid. You'll be able to do this on your own. Anyway, your velocity initial in the y direction is 0, so I can just cross that out. My delta y is actually 1,000 meters, or in this case, I'm just going to call it h. Keep in mind that's negative h, because if you think about it, the height that it ends up at is lower than the height that it started at. So the distance that it fell is negative h, because it fell down. Equals 1/2 gt squared, but it's negative g because gravity is also pointing down as well. Did I trip you out, or are we good? Then you simply want to solve for t at this point. What's up, Catherine?
Nah, that's good.
All right. You simply
So
want
these are all just like formulas at this point, right?
Yeah, and to be honest with you, there's only one formula we've been using, like for the last 2 weeks. All right. Yeah, this is straight up from the course. This is how I solve things in the course. So your delta y is equal to v naught t plus 1/2 at squared. That's the only equation we've been using. So all these new equations that I throw out and come up with and all that kind of stuff, I don't memorize any of them. I really just take it and apply the same equation to it. Cool? All right.
Okay.
So I got to solve for t. Do you guys mind if I just do the algebra in my real quick? The negatives cancel. The 2 can get multiplied up. Divide both sides by g. So t is equal to the square root of 2h over g. You guys can do algebra pretty quickly, right?
Yeah.
All right, cool. So now what I did was I figured out how long it took for the bomb to get from here to here. In essence, what I said was a bomb that gets dropped from here to here is the same, it would take the same amount of time as if the helicopter were stationary and just dropped the bomb straight down. I've actually shown you in a physics demonstration that that's true. So this is how long that would take. Now what I do is I can take that idea of the y direction and apply it to the x direction. So the different variables I have is the v final, v initial, acceleration, time, delta x in this case.
Wait, what is it we're trying to find here?
I'm trying to figure out how far it went, r.
Okay. And in that equation that you have circled there, what is g?
G is gravity.
That's the 9.8, right?
Yes, it's 9.8 meters per second squared. If you are, of course, using meters and whatnot. If you're using miles per hour, then the answer is 32 feet per second squared. It's just converting the units.
Okay.
All right, we good?
Yeah.
So, of the 5 variables, in the x direction, I know my velocity initial in the x direction. That's 100. I know my acceleration in the x direction. I know my time as well. It's whatever this thing.
Wait, how do we know the acceleration in the x direction?
All right, well, let me ask you this. If you throw a baseball, does it accelerate in the x direction?
Yeah.
If you throw a baseball, can you make it? All right, let's pretend it's a billiard ball. So we're not talking about like a curve ball or whatever. If you throw a billiard ball, a really smooth one, can you make it go faster or slower in the horizontal direction?
No.
So what is your acceleration in the x direction?
No?
Exactly. I mean, if you think about it, the only
Wait,
thing that's
does it not slow down though?
we're assuming there's no air resistance. To be honest with you, I don't even know if I can teach you the physics using air resistance in high school. But I can teach you the idealized motion that all of these equations are based on. So no, it doesn't slow down. It actually stays at a constant velocity. It is moving at 100 meters per second over here, and over here it's moving a little faster than 100 meters per second, a lot faster actually, but horizontally it's only moving at 100 meters per second. Does that make sense?
That last statement didn't really make sense, no.
Well, here, the last statement, all I'm saying is in the x direction, there is no acceleration.
Okay.
Okay, all right, here.
Okay.
This is actually a really important concept to get, so I'm going to slow us down and say this. Here's what I mean by that last statement, okay? Your velocity over here is actually going into the ground like this, right? It's not going straight up and down vertically, but it's going a little bit into the ground. Cool?
Mm-hmm.
If I were to break this up into its components, I would have this arrow and I would have this arrow. Are we cool with that?
Okay.
All right. You see this horizontal arrow? Right here? That's going to be the exact same size as the horizontal arrow here. Because the velocity in the x direction didn't change.
Wait, what do you mean the size of the arrow?
What I mean by the size of the arrow is, I guess I'm relating the size of the arrow to the speed. If this thing's moving faster, then I draw a bigger arrow. So what I'm saying is, this value is going to be 100 meters per second. Just like this value is 100 meters per second. But that's talking in the x direction, specifically. Got it?
Mm-hmm.
In the y direction, it's going to be some value, whatever, like 10 or something, I don't know. We can solve for that, that's pretty easy. All you do is you just, well, here, why don't we solve for the velocity it's moving. And then if you were to use the Pythagorean theorem, you can calculate the velocity that thing is actually going at. But as far as the x direction goes, it didn't speed up or slow down. There is no acceleration in the x direction. Catherine, I cannot throw a base... Do you play softball? You look like you're a softball player, to be honest with you.
No.
Okay, all right. I can't throw a baseball at you or a softball at you and then use my mental powers to make it like go and then all of a sudden speed up. Nor can I throw it and then it like comes towards you and right before you hit it, it's going to slow down. I can't change the velocity in the x direction. Does that make sense?
Yeah, that makes sense.
Now I had to stop you from saying, "Oh, isn't so?" What you're saying is the velocity the same here as it is here? And the answer is no, because the velocity here is this arrow right here. It's the diagonal one. The velocity when it hits the ground is way bigger than the velocity that it got released at the air. But that's only because the y direction, there's now velocity in the y direction. The x direction didn't change the velocity. Are we cool?
Yeah.
All right. Okay. So, I know the velocity initial, I know the acceleration, I know the time, I know the delta x. Actually, I don't know the delta x. That's what I'm looking for. So that helps me choose which equation to use of those 4 equations that I gave you last month. The one you're going to want to use, and the one we've always been using this whole time, is delta x equals v naught t plus 1/2 at squared. Delta x is what we're looking for. It's called r, which stands for range. Sorry, it's the pen is running out. Your acceleration is 0, so we're good there. Your velocity, you know that, it's just 100. And your time, you can just plug in here. So v naught times the square root of 2h over g is equal to my range. I can plug those answers, or those equations, into my calculator and figure out exactly how far this bomb went in order for it to hit its target. Do you understand this process?
Sure.
Okay.
Yeah.
One of the things I like doing is I like checking my work. Velocity is measured in meters per second. The square root of 2 doesn't have units, so I'm just looking at the units here. H is measured in meters. Acceleration is measured in meters per second squared. So if I take this divided by this fraction, I can take this fraction on the bottom, flip him over, take the square root of that, and that gives me seconds squared. So I'm left with meters per second times seconds. Those cancel out, and I get meters for my units. So this right-hand side has the units of meters, which is a good thing, because the left-hand side has units of meters as well. If this was the units of meters and this was units of meters per second, we'd have a problem. Cool?
Yep.
All right. Now, just because I'm curious, and this wasn't a part of the problem set, I'm going to erase this. Just because I'm going to try something out, this wasn't a part of the problem set, but you can ask the question, why don't we? How fast was that thing moving when it hit the ground? So, I guess the question is, how long is this arrow? The diagonal one. Well, I can tell you how long the horizontal part of that arrow is. That's 100. Ah, the pen doesn't work. Can you guys see this blue, or this pink? Alright. I can tell you how long that horizontal part is. That's 100. There's this vertical part that I have to calculate out, and that's what I have to figure out. I'll label this as, this is V final, this will be V final X, and this will be V final Y. We cool?
Okay.
So, if I want to figure out what V final Y is, I'll look in the Y direction,
It's
obviously.
gravity, right?
What is that?
Isn't it gravity?
No. Keep in mind,
Why not?
Catherine, that gravity is an acceleration. What we're looking for is your velocity. Speed and acceleration are two things that are totally different from each other.
Okay.
All right. So your y direction, if I'm looking in the y direction, I'll just use my same equations or same variables. Delta y, I have v final, I have v naught, a, and t. The question is, I kind of always write down these 5 equations up on the board, or these 5 variables up on the board, and then try to figure out what it is that I know and what it is that I don't know. Delta y, I know. Check. V initial in the y direction, I know. Check. Acceleration, I know. Check. V final, I'm looking for, question mark, but that's still important to me. So the one thing that I don't know, nor do I care about any information about, is the time. Catherine, or Julia and Catherine, do you guys have those 4 equations that I wrote up on the board for you guys and told you guys to make sure you guys write that down? Do you have that somewhere in your notes?
Yeah.
Okay. What I want you to do is, and I want you to take a look at this, but for time's sake, I'm just going to tell you the answer. Look at those 4 equations and figure out which equation to use based on the fact that you don't have any information, nor do you care about any information about the time. The equation you'll find is it's going to be v final squared equals v initial squared plus 2a delta, well, it's a delta x in your book, but I'm going to change it to a delta y because we're talking about the y direction. Are we cool with that? So v final is what I'm looking for. V initial was 0. Acceleration is this. V final equals 2gh, because delta y is the same as h. Or, I'm sorry, it's v final squared equals 2gh. And I'm going to square root both sides. By the way, there's something I did that kind of cheated, and I don't know if you caught it. See this acceleration? That's actually supposed to be negative g. Right? But I didn't write the negative g in there because that delta y, that's actually also supposed to be negative h. And that negative g and the negative h, they just kind of wash each other out. You multiply 2 negatives times each other, that gives you a positive. So we're good. So, apparently, this thing is moving with a velocity of whatever the square root of 2gh is. We cool?
Okay.
Alright. So you plug your answers into that calculator. I don't know. What is the square root of 2 times 9.8 times 1,000? I don't actually have the calculator to do that.
I don't either.
Okay. Let me see. Let me just type that into the chat bar. Square root of 2 times 9.8 times 1,000. Come on. I typed it into Google. It's 140. Got it. So this is equal to 140. And if you want to figure out what the velocity final of this thing is, you now know the 2 components. This thing is 100 going to the right, 140 going down. So this thing is the Pythagorean theorem, a squared equals, or c squared equals b squared plus a squared. I said that totally backwards. I'm sorry. I don't know why I did a dyslexia on that thing. A squared equals b, a squared plus b squared equals c squared. You would just kind of plug that into there and you would get the velocity that it would be moving at. So you can figure out the velocity that that bomb is going when it hits the ground. We cool?
Okay.
Alright, how's your brains doing? Alright, let's do this one. The rocket missile. You know what, the rocket missile is pretty straightforward. I think that what I want to do is angle of 3 degrees. Yeah, let's do the grenade. Alright, let's see. This dude named Leaf just... Do you guys see a picture of a grenade on the screen?
Yeah.
Okay, I'm just wondering. Alright. Leaf just finished unloading the hover bike and was started by the alarm screaming that in the cockpit. Instinctively, he grabs Melina and zooms off, knows that there's an incoming missile. It happens so quickly. Leaf couldn't successfully hoist me, and she dragged it, blah, blah, blah. Alright, here we go. Melina is able to climb onto the bike, and the missile hits the jet, and an impact throws them 20 feet into the air. Dude, there's a bunch of story. There's no actual problem that they're asking for. Oh, okay. Well, let's just do the problem number 4. Carrie throws an impact grenade from the top of Doe Library at an angle of 30 degrees to the horizontal with an initial speed of 20 meters per second. If the height of the building is 45, how long does it take before the grenade hits the ground? Oh, okay. Alright, so essentially I'm doing a very similar problem here. I'll show you the problem. We got this girl. She's standing on top of a building. Here's the building. She throws a grenade like that. We cool? The velocity she throws it at, did I give it to you? Was 20.
I'll be right back.
What was that? Alright. The velocity was 20. The angle was 30 degrees. Is that visible? Can you guys see that?
Not really.
Ah, this is such a frustrating day. Alright. Hey, wait, 1 second. Let me try this. Try making this. I wonder if I can do this. Okay.
I'll be right back.
Yeah, got it. Do you mind if I keep teaching? You know what? My camera just died on me. I'm gonna have to stop class because actually we're done with class pretty soon in about 4 minutes. I'll record a video for you guys later on.